Hi everyone, welcome to Mathworld. This video is to discuss Cambridge International AS and A-Level Further Mathematics Paper 2, which is a Further Pure Mathematics 2 for May-June 2023, and the code is 9231/21. Okay, so the contents of this paper will be the same as 9231/22. Alright. First question, 1a. Show that the system of equations, these are the three linear equations, does not have a unique solution. So, for your information, if it does not have unique solution, no unique solution, that means the determinant will be 0. Okay, so that is how we show this. Means now I need to get the determinant of the matrix. So, for your information, from these three system linear equations, the matrix, right, I can change to 1, 2, 3. All these are the coefficients for x, y, and z. Then the second row will be 4, 5, 6. Then 7, 8, 9. I will express in the multiplication of three matrices first. Then from here, I will get the matrix M, okay, or A. So now, determinant of 1, 2, 3, 4, 5, 6, 7, 8, 9. Then to get this calculation, I will fix one row. Okay, so I will fix the first row and then consider the sign here, plus, minus, and plus. Now, followed by fixing or considering the column. So when I consider the first column, the cross out will be 1. So which means I will get plus 1. The plus because of the sign over here. Then the remaining 5, 6, 8, 9 will be my determinant of 2 by 2 matrix. Then after that, I will consider the second column. So when I consider second column, right, so obviously the cross out is 2 and the sign is minus. So I will get minus 2, and then the remaining 4 numbers will be 4, 6, 7, 9. Alright, and then now I will erase the second column, and now I fix the third column, or I consider the third column. So obviously the cross out is 3 and the sign is plus, so I will get plus 3, then 4, 5, 7, 8. Then now I have reduced 3 by 3 matrix to 2 by 2. I mean the determinant of 3 by 3 matrix into the 2 by 2 determinant. Okay, the determinant instead of 3 by 3 have been reduced to 2 by 2. So now very easy, just a red arrow minus the green arrow. Okay, that is how we calculate the determinant of 2 by 2 matrix. 2 by 2 determinant of 2 by 2 matrix. So here will be plus 1. So I will just write 1. Then you multiply the red minus the green. So I will get 5 times 9 minus 6 times 8. Then minus 2 bracket 4 times 9 minus 7 times 6 plus 3. Then 4 times 8 minus 7 times 5. Okay, so when you calculate the first one, it will be 45 minus 48. Then minus 2 bracket minus 6. Right, 36 minus 42. So I will write 36 minus 42, then plus 3, then this is 32 minus 35. So when you calculate these values using calculator, at last you will get 0. So right here, determinant equals to 0. Hence, the system linear equation, the system equation does not have unique solution. Okay, so that is the solution. Now B, show that the system of equations in part A is consistent and interpret this situation geometrically. So consistent means it can be a unique solution. It can be unique. Okay, it can be infinite solution. Alright, so we can accept these two types of solutions to classify the system of equations as consistent. So to show this, we need to use row operation method. Alright, so I will change this multiplication of the equations in this form into the augmented matrix so that I can carry out the row operation. So 1, 2, 3, then 1, 4, 5, 6, 1, then 7, 8, 9, also 1. Okay, so according to the elementary row operation, we need to try to get the 0, the 3 zeros here. Okay, we need to try to get zeros here. Alright, so it means that I will remain my first row and I'm changing the second row. So when I change the second row, since this is 4, I need to times minus 4 to the first row. And now the 4 is the elements in the second row and first column. So my row operation here will involve row 1 and row 2. Okay, so it depends on the position of the entry. So I will write minus 4R1 plus R2 to make it to 0. So I will remain 1, 2, 3, then 1. So the first one will be 0. Now, when you times minus 4 to 2, it will be minus 8. Minus 8 plus R2, so means plus 5. So I will get minus 3. Okay, and then the 3 multiplied by minus 4 is minus 12. Then you plus 6, it will be minus 6. Now, the 1 here, you times by minus 4, it will be minus 4. Then you plus with this 1, it will be minus 3. Now, we need to convert the 7 into 0. So again, since this 7 is in third row and first column, that means our row operations here will involve row 1 and row 3. So obviously, I have to times minus 7 to the first row, this one, it will be minus 7, then plus with 7, it will be 0. So the operation here becomes minus 7 R1 plus R3. So the first one definitely is 0. Then the second value, 2 times minus 7 here will be minus 14. Then you plus with the 8, it will be minus 6. Okay, and then the minus 7 times 3, it will be minus 21. Then you plus with the 9, it will be minus 12. So same goes to the last value, minus 7 times 1 plus 1, it will be minus 6. Okay, once we get this, now the next step is to get this 0. Okay, the minus 6 must be converted to 0. So then it will just involve the row 3. Then I will rewrite first two rows. Okay, so now this minus 6 is the elements of A2, it is A23, sorry, A32. Okay, A32. So which means it is in third column and it is in third row and second column. That means our operations will be involving row 2 and row 3. Okay, so now when row 2 and row 3, when you look at these two numbers, I need to times negative 2 to the row 2 to make it to positive 6. Then I plus with the third row. So negative 2 row 2 plus row 3. Okay, so I will get 0. Then the next one is 0. Then the last one, minus 6 times minus 2, it will be positive 12. So positive 12 plus minus 12 over here, it will be 0. Okay, and same goes to the last one. So minus 3 times minus 2, it will be positive 6. Then you plus with minus 6, it will be 0. Okay, so you can leave it in this form, or if you want, you can just simplify the second row. So I simplify the second row by multiplying negative 1 over 3 to the second row. I will get 1, 2, 3, 1, 0. So when you times negative 1 over 3 to the second row, it's like you divide by negative 1 over 3, divide by negative 3. So I get 1, 2, and 1 here. Then 0, 0, 0, 0. Or 0 for the last row. Okay, once you get this, obviously you can form two equations. Okay, so the first one, we write x 1x plus 2y plus 3z equals 1. And then the second row will be y plus 2z equals 1. So you only have two equations, but we have three unknowns. Okay, so this gives give infinite solution. Okay, because of lack of one equation. So that means the system equations is consistent. Okay, so consistent means it can be unique or infinite. So we have done the first part. Now interpret this situation geometrically. So since it has infinite solution over here, infinite solution means that you can interpret this as two ways. The first one is, so this is the interpretation. So you can say that three planes form a sheaf. So the sheaf here means that sets of all planes that have the same common line. Okay, you can either write this or you can write three planes intersect along a common line. Okay, so that's the solution of this question. Question number 2. Use the substitution z equals to x plus y to find the solution of this differential equation where y equals to 0, where x equals to 1. Give your answer in this form, in the long form, where a, b, c are constants to be determined. Okay, so now, first of all, I will rewrite the differential equation. Okay, so now you are given the hints. Let z equals to x plus y. Then from here, we need to get dz over dx. Okay, so when you differentiate differentiate x with respect to x, it will be 1. Now, differentiate y with respect to x, we need to apply the implicit differentiation. This is the formula. So when you differentiate fy with respect to x, it will be differentiate the function of y with respect to its variable. Then you times dy over dx. Alright, so now here, when I apply this formula, so when I differentiate my y, this is my y, with respect to y, it will be 1. Then multiply with dy dx, which means this is basically 1 plus dy dx. Okay, then from here, since you are given dy dx, which means now my dy dx is basically moving the 1 to the other side. That is the dz over dx minus 1. Okay, so now I will replace it. The left hand side becomes dz over dx minus 1 equals to, remember, your z is x plus y. Okay, so from here, I can just write this is 1 plus 3 bracket x plus y. Alright, so probably from the first step, instead of copying, I will just change, simplify. So instead of 3x plus 3y, I will write 3 bracket x plus y. Then for the denominator, it will be the same. I will factorize the 3. So it will be 3 brackets x plus y minus 1. So I will direct change the brackets to z. Then it will be 3z minus 1 in the denominator. Okay, so after this, we need to move the -1 to the right side first. So you move this to right side. Then now, my dz dx, it will be 1 plus 3z over 3z minus 1, then plus another 1. So again, from here, I will get the same denominator. So 3z minus 1, so 1 plus 3z for the numerator, plus, so when you times, when you make it to the same denominator as 3z minus 1 means that you are multiplying that two terms with 1. Okay, which means I will be getting 3z minus 1. Then from here, when you simplify, it will be 6z over 3z minus 1. That is my dz over dx. Okay, then from here, I have reduced it to just one term on both sides, means that this can be solved using separable variable method. So I will move my z to the to the left side because my dz is the numerator. So it means that I will get 3z minus 1 over 6z dz equals to dx over here. But don't forget to add the integration sign both sides. Okay, so to integrate this, the term on the left hand side, since numerators has two terms, the denominator only one term, I can split it into two terms, which means 3z over 6z minus 1 over z dz. That equals to integrate dx. So the first term will be simplified to just half. Then the second term is 1 over z. Okay, then now integrate half with respect to z is basically 1 over 2z or half z. The second term will be ln. Okay, because our formula is integrate f prime x over fx dx, you will get ln fx plus c. So when I differentiate z with respect to z, it will be 1 here, which means it's exactly the same as this. Therefore, I will just write ln z. Okay, then supposedly there is a plus c, but then since right hand side also without limits, this is an infinite integral, so I will plus c on the right side later on. Alright? Okay, so now be careful with this. This is 6z, but here I just wrote z, so I should have another 6 in the denominator. Means that I will factorize a 1 over 6 and then integrate 1 over z will be ln z. So I will always put the modular sign here, okay, to make sure that it is positive. Then integrate dx, it will be 1. So this is actually integrate 1 dx. Then you will get x, then plus c. Once you get this, right, remember, you are given the limits. X is 1, y is 0. So now I will change back. My z is x plus y. Alright, so z is x plus y given. Therefore, I will get 1 over 2 bracket x plus y minus 1 over 6 ln. Okay, so from here, since it is ln, right, it will be positive. So if you want, you can just ignore the modulus now, because in the answer is using bracket instead of modulus. So I will just write bracket, then x plus y. That equals to x plus c. So now replace the given values. So you are given y0, x is 1. So when y0, x is 1, I will get half bracket 0 plus 1, it will be 1, minus 1 over 6 ln 1 equals to your x is 1, then plus c. So now for your info, ln 1 is 0. Therefore, from here, your c will be this half, and this 1 will be moved to the left side. So minus 1, therefore it's negative half for the c. So now final answer, just substitute back into this solution. It will be half of x plus y minus 1 over 6 ln of x plus y. That equals to x. The plus c becomes minus half. Okay, so right now I'm getting this solution. Let's look at the given form. Your given form is all the terms on the left hand side, and then here is a ln x plus y. So it means that I will just make sure all the terms are on the left hand side. And don't forget, the first term with ln, second term with x minus y. Okay, So from here, I will just move all the terms to the right side, okay, because I want to get positive. So I will move all the terms to the right side now, just to make sure one of the sides is 0. So I will get 1 over 6 ln x plus y. Then I move this to the right side as well. So minus half x, I do expansion, and then minus half y, and plus with the existing terms on the right side, plus x minus half. Then I will get equals to 0. So from here, 1 over 6 ln x plus y. Now, when you simplify, see here, minus half x plus x, it will be plus half x. Then minus half y minus half equals to 0. So when you refer to the answer over here, second term should be b bracket x minus y. So it means that I need one more step, right? Which means here, 1 over 6x ln x plus y, the half will be taken out. So plus half bracket x minus y, then minus half equals to 0. That is my final answer. Okay, so this is the solution for question number 2. Now for question number 3, A, by considering the binomial expansion of degree 4 for z plus z power negative 1, where z is cos theta plus I sin theta, use De Moivre's theorem to show that cos theta to the power 4 equals to this form. Okay, so first of all, I have to consider what is the sum for these two terms. So z plus z power negative 1 is basically z plus 1 over z. So your z is cos theta plus I sin theta. Then the 1 over z is basically, according to the De Moivre's theorem, it will be cos negative theta plus, or I would say, I do it step by step. So cos theta plus I sin theta to the power of negative 1. Okay, because of this negative 1. Right? That means you will get cos theta plus I sin theta plus, okay, according to De Moivre's theorem, you can just bring in the negative to the theta. Then from here, I will get cos theta plus I sin theta. Then plus cos negative theta is basically cos theta. Sin negative theta is negative sin theta. Okay, this is negative sin theta. This is cos theta, positive value. So here minus sin minus I sin theta. Then at last you will get 2 cos theta. This is our result. Okay, then now you need to get z plus 1 over z to the power 4. So I will start with that. So from here, it is same as, okay, I will just write 1 over z, right? Then from here, I will get binomial expansion. So for binomial expansion, you can refer to the Pascal triangle. So if let's say a plus b degree 0, the coefficient will be 1. Okay, a plus b degree 1, it will be 1, 1. Because 1a, 1b. Then for degree 2, I will always add the 1 in the front and at the back. So the middle will be sum of these two numbers, which is 2. So a plus b degree 3, it will be 1, 1. Then plus together 3, here plus together 3. Then for a plus b degree 4, it will be 1 and 1. Then plus together is 4. Then here plus together 6, plus together is 4. So these are my coefficients for the binomial expansion using Pascal triangle. So my first term is z degree 4, the coefficient is 1. Then the coefficient for the next term is 4, z cubed 1 over z degree 1. So we always drop 1 degree from the first term and increase 1 degree from the second term. So now my next term is going to be z squared. Then 1 over z squared plus 4z 1 over z cube, then plus 1 over z degree 4. Okay, so then from here I will get z4. So when you simplify the second term, z cube over 1 over z is actually squared. Then the third term will be just 6. Now the next term is z over z cube, which means you are getting 4 brackets 1 over z squared, and then lastly it will be 1 over z degree 4. Then from here I can group the first and last term. I will get z degree 4 plus 1 over z degree 4 as one term, and then second and the fourth term will be grouped together by factorizing the 4. Then you get z squared plus 1 over z squared, and then lastly I get 6. Now for the left hand side, remember here, this is 2 cos theta, which means now I will change to 2 cos theta degree 4, okay, because of here. Then equals to, now z degree 4 plus 1 over z degree 4. Now we can just extend this formula, right? So if let's say here is degree n, here is degree n, let's say for example, then here is degree n, I will have degree n, and then here is also degree n. Right? So then this n will be brought into the theta. So then when you add together, I will get cos n theta over here. Alright, same for all this. So which means now here I will get another important result, which is z degree n plus z degree negative n. It will be 2 cos n theta. Okay, so sorry, this is my important formula. So now I will replace z degree 4 plus 1 over z degree 4. So just, sorry. Okay, so now I will replace my n by 4. So it means that I will get 2 cos 4 theta plus 4 bracket 2 cos 2 theta, because my n is 2 now, then plus 6. Okay, then now let's look at the question. You need to get degree 1 of, the coefficient for cos degree 4 is 1. So now I will do the expansion. This degree 4 will be brought into both of these two terms. So 2 power 4 is basically 16. Then cos degree 4 theta equals to 2 cos 4 theta plus 8 cos 2 theta plus 6. Then now I will move down, or I will say that all the terms can be divided by 2. So here becomes 8. This one no more. This one becomes 4. And this is 3. So then I will just move down my 8. So cos degree 4 theta, it will be 1 over 8 bracket cos 4 theta plus 4 cos 2 theta. Then plus 3. Okay, so that is the form that we need to prove. Right, now B, use the substitution x equals to sine theta to find the exact value of this integration. So I will start with x equals to sine theta. Then now, when you look at this integration, we need the dx, means that now I need to get dx over d theta. It will be cos theta. Okay, then now my dx, it will be cos theta d theta. And then we are given two limits. So when x equals to 0, 0 equals to sine theta, that means your theta equals to 0. Then when x equals to half, half equals to sine theta, that means your theta is inverse sine half, which is pi over 6. So you have to leave your answer in radians. So now I will substitute all this into my integration. So it will be 0 to half. 1 minus x squared degree 3 over 2 dx. Okay, so from here, I will get 0 to half. No, I have to change my limits. So when x is 0, theta is 0. When x is half, theta is pi over 6. So here is pi over 6. Then 1 minus, this is my x. So it will be sine square theta. Then after that, degree 3 over 2. So for the dx, replace the dx by cos theta d theta. So which means now I will get cos theta d theta. Okay, so we have a formula here. 1 equals to sine squared theta plus cos squared theta. This is the identity. So now I get 1 minus sine squared. So move the sine squared to the other side. It will be cos theta. Cos squared theta. Okay, sorry. Cos squared theta. So then here I will replace this by cos squared theta. So now I will get integrate 0 to pi over 2 cos squared theta with degree of 3 over 2, then another cos theta d theta. So when you look at here now, the degree half and 2 will be cancelled off, which means I'm getting degree 3 for the cos theta in the bracket. And together with another cos theta outside, it becomes degree 4 of the cos theta. So I'm integrating 0 to pi over 2, sorry, not pi over 2, pi over 6 cos degree 4 theta. So this is what I need to solve right now. Okay, so now to integrate cos degree 2 or degree 4, I have to refer to the double angle formula. So now for degree cos theta for degree 4 of cos theta, I will change to cos squared theta, then another squared outside. And then now for your information, to integrate cos squared or sine squared, you need to refer to the cos 2a formula. So here we have two forms. Basically, we are referring to these two forms, okay? So either 2 cos squared a minus 1 or 1 minus 2 sine squared a. So obviously, we are using this one. So now, when I rewrite 2 cos squared a minus 1, now look at here. I need cos squared. Means that this minus 1 will be moved to the other side. Then I will get cos squared a equals to half of 1 plus cos 2a according to this formula. Okay, so which means I will get my half, which is equals to integrate 0 to pi over 6 half of 1 plus, now cos squared a, this is a, and then the question, it is theta, which means your a equals to theta here. Right, I will get cos 2 theta. So this whole term will be my cos squared theta, then another squared outside. Okay, so now I will continue my integration over here. So then, now my integration becomes, bring in the squared. So when you bring in the squared, right? So 1 over 2 squared becomes 1 over 4. I will factorize the 1 over 4. So I will get 1 over 4, integrate, then 0 to pi over 6. Then now I will do expansion for this bracket. It will be 1 plus 2 cos 2 theta plus cos squared 2 theta d theta. So 1 over 4 integrates 0 to pi over 4, remain first two terms. But the last term, again, cos squared 2 theta. Okay, so this cos squared 2 theta, you refer back to this formula, okay, this identity, but then now you let the a be 2 theta. So when you let a be 2 theta, that means this one becomes 4 theta. Okay, so I will direct replace now. So it will be half of 1 plus cos 4 theta. So this is my integration. These are the terms that I need to integrate. So now I will integrate term by term. Alright, so for your information, this 1 and this half, when you add together, it will be 3 over 2. So when I integrate 3 over 2, it will be 3 over 2 theta. Then now, to integrate 2 cos 2 theta, I will remain the 2. Integrate cos is positive sign. So it will be sine 2 theta. Then it differentiate 2 theta, it will be 2. So we have to divide by 2. And this half multiply with the cos 4 theta. I will keep the half outside. Again, integrate cos 4 theta, it will be sine 4 theta, then over 4. So limits 0 to pi over 6. Okay, so here I will write 1 over 4. Then you can simplify first. So the half and 2 cancel off. This becomes 1 over 8. Now I will just direct replace the limits right now. 3 over 2 pi over 6 plus sine 2 times pi over 6. It will be pi over 3. Then 1 over 2 and the over 4 here, it will be 1 over 8 sine 4 pi over 6. Okay, minus when the theta equals to 0. So when you replace the theta by 0 here, all the theta, so the first one is 0, sine 0 is 0, last term also 0, means that everything is 0. Okay, and then let's look at the question. Find the exact value. Exact value means no decimal. So now I will get 1 over 4. This is going to be, okay, 3. So this one can be cancelled off. Pi over 4. Okay, then sine pi over 3 is basically square root 3 over 2. Then 1 over 8 sine 2 over pi 3, it will be square root 3 over 2. Okay, so now leave your answer in the simplest form, means that I will do expansion right now. So it will be probably, okay, now to simplify this, probably we can just times or factorize the largest denominator. So obviously the largest denominator is 16. So 16 times this 4, it will be 1 over 16 times 4, it will be 64. Okay, so I will factorize 1 over 64. So it means that the first term I multiply by 16. So 16 times 1 over 4, it will be 4. Okay, so the second term here, I will times by 16. So it means that it will be 8 square root 3. And then the last term, it will be 1 square root 3. So at last, I will get 1 over 64 times 4 pi. Then last two terms plus together, it will be 9 square root 3. Okay, that is my exact solution of this integration. Okay, now for question number 4. The integral In is defined by, In is this integration, by considering the differentiation or otherwise show this formula. Okay, so since the hint is given by considering the differentiation, that means I will start with the differentiation first. Okay, now when you differentiate, we need to apply the products rule. So d over dx uv, it will be u v prime plus v u prime. Okay, so now I will show you step by step. Let's u equals to x. This is my u. Then my u prime will be 1. My v is 1 plus x degree 5 to the power of n. So my v prime here, it will be applying the power rule. This is the power rule. So you differentiate fx degree n. You bring down the n, remain the fx, then degree n minus 1. After that, you differentiate fx by using f prime x. So now first of all, I will bring down the n. Then I rewrite the whole bracket. The degree becomes n minus 1. And now I differentiate the brackets. It will be 5x degree 4. So basically, I'm getting 5nx degree 4 bracket 1 plus x degree 5 bracket n minus 1. That is my v prime. Okay, so now I will apply this product rule. Then it will be uv, so x times this. Sorry, uv prime, x times v prime. So it will be bracket 5n x degree 4, then 1 plus x degree 5 to the power of n minus 1 plus v u prime. Okay, so you multiply by 1, it will be the same as the v. So 1 plus x degree 5 to the power of n. Then from here, right, I will simplify the first term. So the first term, when you see the x here, and this is x degree 4, it becomes x degree 5. So I will get 5n x degree 5 brackets 1 plus x degree 5 to the power of n minus 1 plus the next term. Okay, we know that when you differentiate y, or probably I will just write y, you differentiate the y to get dy dx. Okay, so now this is the term. Alright, means that we need to integrate, because when I integrate both sides, integrate right side, it will be same as this result. Why do I need to integrate right side? I need to get this term. I need to get these terms. Alright, so which means here I need to integrate my right hand side. Okay, so when I integrate my right hand side, I will write left hand side with limits, because my integration with limits 0 to 1. So now I will write limits. I will add on the limits. So here 0 to 1 equals to integrate right hand side based on this result. I split it into two integrations. Okay, so for the left hand side, you can just directly replace the limits now. Okay, substitute into x. So I will get 1 bracket 1 plus 1 degree 5 is 2 degree n minus 0, because when the x is 0, everything is 0. Okay, so maybe I just show step by step, then it will be better. 1 plus 1 degree 5, then degree n minus 0. Okay, then for the right hand side, since the 5n is a constant, I can take up the constant. Then I will get integrate 0 to 1, x degree 5 brackets 1 plus x degree 5 to the power of n minus 1 dx. Then plus this whole term is in. Okay, when you look at the question, because this is your in. So I have found one in here. But then we need to prove this. Okay, so for the 1 in, I already found this term, but I need to get 5n in as well. Then I have in minus 1. So for the left hand side, 1 plus 1 degree 5 is 1. 1 plus 1 degree 5 is 2. Here is 2. So 2 times 1, it will be 2. So 2 degree n on the left hand side. Then now, for the 5n here, you look at this 5n must have in. So it means that I need to get this term from the first integration. So I already have 1 plus x degree 5 here, right, with the n minus 1 degree. It's just that now I have extra x degree 5. So what to do is I will change the x degree 5 to 1 plus x degree 5, then I minus 1. So which means it's like 0 to 1, integrate the limits. Then instead of the x degree 5, I will write x degree 5 plus 1, then I minus 1. Okay, then I group the x degree 5 plus 1 as one term. So when I swap the terms, it will be 1 plus x degree 5. Then multiply with 1 plus x degree 5 to the power of n minus 1 dx, then plus in. Then next step is, alright, I will treat this as one term and then multiply to this. So it is exactly the term, exactly the same term. It's just that degree 1 here, and this is degree n minus 1. So when you have same base, a degree m times b degree n, right, sorry, same base. So here times a degree n, it will be a degree m plus n. Okay, so then from here I will get 5n integrate 0 to 1. Then when I plus together, it will be just 1 plus x degree 5 power n. Okay, then minus the another expansion is just times this minus 1 to the right side, to the next term. Then I will rewrite. Alright, so from here I will split it into two integrations. Put a bracket, because multiply by 5n, then plus in. Then from here I will get 5n. This is my in. Then now if you look at the definition here, when here is n, this is n. Means that if this I have changed to n minus 1, which means this is in minus 1. Okay, so which means this is degree n minus 1 here. Therefore, I will write in minus 1. Okay, so now I will do expansion. 5n in minus 5n in minus 1 plus in. The left hand side is 2 power n. Then now look at the question here. You need to prove the in on left hand side, the rest of the terms on right hand side. So now I will take out, or I will factorize the in from the first and third term. That means I will get in bracket 5n plus 1. Then remember the one with the in on the on one side, then the rest of the terms on the other side. So it means that the second term will be moved to the other side. So I will get 2 power n plus 5n in minus 1. Okay, so I just need to rewrite so that it will be in the same form. So I will get 5n plus 1 in equals to 2 power n plus 5n in minus 1. Okay, so shown. So this is the solution of this question. Next, find the exact value of I3. Okay, so for I3, we need to use the formula that we have just proven. So I will rewrite this formula. Okay, 5n plus 1 in equals to 2 power n, then plus 5n in minus 1. We need to get I3. So I will let n equals to 3. So now 5 times 3 plus 1 multiply with I3, it will be 2 cubed plus 5 bracket 3 I2, because your n is 3. 3 minus 1 is 2. So from here, my I3 is, here, it will be 15 plus 1, which is 16. So I move down this 16, it becomes 1 over 16. 2 power 3 is 8 plus 15 I2. I let this be the first equation. So it means that instead, in order to get I3, I need I2. So now I will replace the formula, this formula, the n by 2. Okay, so I will get 5 bracket 2 plus 1 multiply with I2 equals to 2 power 2 plus 5 bracket 2 I1. Because my n is 2, 2 minus 1 will be 1. So now from here, my I2 is going to be, okay, when you solve this bracket, it will be 5 times 2, 10. 10 plus 1 is 11. I will move down this 11. So it will be 1 over 11. 2 squared is 4. Plus 5 times 2 is 10. Then I1. This is my second equation. So now, my I1, I can refer to the formula. Okay, the integration. So go back to the definition. In is this integration. So when I1 means that just replace this by 1. That means you are integrating 1 plus x degree 5 with respect to x from 0 to 1. Okay, so this is a very simple integration. That means I will just use the definition. So 0 to 1, 1 plus x degree 5 dx. So when you integrate this, it's going to be x plus x degree 6 over 6, limits from 0 to 1, and then you replace the x by 1 and 0. So when I replace by 1, it will be 1 plus 1 over 6, minus, when replaced by 0, everything is 0. Therefore, my I1 is 7 over 6. Now I substitute this 7 over 6 into second equation, then substitute into first equation. Okay, so I will let this be third. Then I substitute third into second. Means that I'm getting I2. So now my I2 will be 1 over 11 multiplied by 4 plus 10 bracket 7 over 6. Then from here, when you calculate using calculator, it will be 47 over 33. Then now I will substitute into the first equation. So from first equation, my I3 is 1 over 16 multiply with 8 plus 15 I2. So my I2 is 47 over 33. Okay, so when you calculate this, again you are getting another fraction, which is 323 over 176. So that is the I3 value. Okay, exact value for I3. Alright, so now let's move on to question number 5. Excuse me. The matrix A is given by this 3 by 3 matrix. A, show that the characteristic equation of A is this cubic equation. This is the first part. And hence means use the cubic equation, find the eigenvalues of matrix A. So we have to solve two parts here. Now, to get the characteristic equation, we will start with determinant of A minus lambda I equals to 0. Okay, so now this is basically 18, 5 minus 11, 8, 6 minus 4, 32, 10 minus 20. I get it from the matrix A. Alright, sorry. It should be A minus lambda I. So I have to minus lambda. I should write this bracket 5, 6, 10 minus 11 minus 4 minus 20. This is my matrix A minus lambda I. I is the identity matrix. Okay, I will start with A minus lambda I matrix first. Then here is going to be 18 minus lambda. Okay, then here 5, then minus 11. Then 8, the middle term you multiply by lambda. That means this is going to be minus lambda from the existing value. So 6 minus lambda minus 4. After that 32 and then 10 followed by negative 20 minus lambda. Okay, so now I need to get the determinant of this matrix. So I get determinant of the matrix equals to 0. Okay, now to get the determinant, let me check the space. Okay, when we get the determinant, we need to fix one row. Right, so I will fix the first row. Then the sign will be plus, minus, plus. for these three elements. And again, use the same method as in the first question just now. We consider column. Excuse me. So when I consider first column, the crossover is 18 minus lambda. Means that now it will be plus 18 minus lambda. Then determinant of the remaining terms. 6 minus lambda minus 4, 10 minus 20 minus lambda. Now erase the first column and consider second column. So the crossout is 5 and the sign is minus. So I will get minus 5, then 8, 32, minus 4, minus 20, minus lambda. And now erase the second row, second column, and now we consider the third column. Okay, so when you consider the third column, the crossout is minus 11, but the sign is plus. Therefore, you get minus 11. Then the remaining entries will be 8. 6 minus lambda, 32, and 10. And let this be 0. Okay. So again now, to solve the 2 by 2 determinant, the green arrow minus the red arrow. Okay. So now the first one will be 18 minus lambda. Then 6 minus lambda multiplied with negative 20 minus lambda minus 10 times negative 4. Then the next one is 8 times negative 20 minus lambda, then minus 32 times minus 4. For the last one will be minus 11, bracket 8 times 10 minus 32 times 6 minus lambda. That equals to 0. Okay, so from here, 18 minus lambda, and now we need to do expansion. So just expand. Right? So then from here, you will be getting negative 120 minus 6 lambda plus 20 lambda plus lambda squared when you do expansion for the brackets. And then the last term here will be plus 40. Okay, then plus 5. So again, multiply here, and then this one multiply, here multiply, multiply. Alright, so the first one will be minus 160, then minus 8 lambda. Then after that, minus 32 times minus 4, it will be plus 128. Okay, then minus 11, bracket, 8 times 10, it will be 80. 32 times 6, it will be 192, but there is a negative, so minus 192. So minus 32 times minus lambda, it will be plus 32 lambda. Okay, so lastly, I need to further expand it, right? So before I expand it, because we have so many terms inside the brackets, so better to simplify first. Otherwise, your expansion will be very long. So I will just write 18 minus lambda. So inside the brackets, there are so many terms. It will be simplified into lambda squared plus 14 lambda minus 80. Okay, and same goes to the second bracket. It will be minus 8 lambda. So minus 160 plus 128, it will be minus 32. Then minus 11. Last term, it will be 32 lambda. 80 minus 192, it will be minus 112. Okay, then now final expansion. Just do another round of expansion. Just expand. I will get 18 lambda squared plus 252 lambda minus 1440. Okay, then here you expand. Minus lambda cubed minus 14 lambda squared plus 80 lambda. So I get all these terms from the first expansion. And then plus, here when you expand, it will be negative 40 lambda. Okay, wait, I made a small mistake. This one is supposed to be minus because here is minus 5. Okay, here is minus 5. Here minus. This one is minus. So here, when I expand, I will get positive 40 lambda. And then it will be plus 160. Okay, when you do expansion for this, it will be plus 160. Then here will be minus. Then this is 11 times 32, it will be 352 lambda. Then this one is going to be, okay, probably I don't write the bracket. I will just direct times, so minus. Then after that, minus minus is plus. So 11 times 112, it will be 1232 equals to 0. Okay, so when you have so many terms here, this is minus lambda cube. That's the only term that I will write minus lambda cube. Then for the lambda squared, look at here. 18 lambda squared minus 14 lambda squared. Okay, then you will get plus 4 lambda squared. Now, for the lambda, 252 lambda plus 80 lambda plus 40 lambda minus 352 lambda, you will be getting plus 20 lambda. Okay, so lastly will be the constant. All the constants you just simplify. Negative 1440 plus 160 plus 1232, it will be negative 48. That equals to 0. Okay, now from here, you need to show this. Because it is positive, lambda cube means that I need to times negative to whole equations, or I move all the terms to the right hand side. So I will get lambda cube minus 4 lambda squared minus 20 lambda plus 48 equals to 0. So let's check. Lambda cube minus 4 lambda squared minus 20 lambda plus 48. So exactly the same. Alright, we have proven the characteristic equation. So we have done the first part. Now for the second part, and hence means use the answer from first part. Find the eigenvalues of A. Basically the lambda will be the eigenvalues. So now what to do is, you can just use the calculator to factorize this. So now I will get lambda minus lambda plus 4. Okay, lambda minus 6. Then lambda minus 2 equals to 0. Then from here, I will get my lambda equals to minus 4, 6, 2. So which means my eigenvalues will be lambda equals to minus 4, 6, and 2. Okay, so with this, we have done the first part of the question. Now P or B, find a matrix P and a diagonal matrix D such that A degree 5 is PDP inverse. So by referring to the eigenvalues, okay, so basically the D will consist of the eigenvalues and then the P will consist of the corresponding eigenvectors. So now I need to solve the eigenvectors for each of the lambda value. So now when, let's say lambda 1 is minus 4, right? So now I have to substitute this lambda 1 into my A minus lambda I matrix, which is this matrix. Okay? So I will get 18 minus lambda, then the rest remain. So it means that I will get 18 minus minus 4. After that, 5 minus 11. Then here 8, 6 minus lambda minus 4. 8, 6 minus lambda, then minus 4. After that, it will be 32, 10 minus 20 minus lambda. So 32 10 minus 20 minus lambda. Okay, so I better move this. So minus 11. This is minus 4. Then multiply with x, y, z and let it be 0. Vector 0. Okay, 0 vector, sorry, 0 vector. So now simplify this. I will get the 22, 5 minus 11, 8, 10 minus 4, 32, 10 minus 16. Then x, y, z equals to all zeros. 0 matrix or 0 vector. Then now I have to form 3 equations and solve. Okay, so I will get 22x plus 5y minus 11z equals to 0. First equation. Second equation, 8x plus 10y minus 4z equals to 0. So I notice that all of this can be okay, later on I will multiply. I will leave it first. Then the next one is 32x plus 10y minus 16z equals to 0. So I need to solve the simultaneous equation to get the eigenvectors. So which means I will try to make the second equation as the same term as the 32x. Means that I have to times 4. Then I will solve these two equations. Alright, so here I times 4. So when I times 4, I will get, probably I will just label this as second equation first, then it will be easier. Second equation and third equation. So the second equation I times 4. Then I will get 32x plus 40y minus 16z equals to 0. Okay, so now when you look at here, here is 32x, this is also 32x. Instead of 2, I have changed to fourth equation. So now I will plus both together. Right? So 3 third plus 4th. So when you plus together, the x will be cancelled off. Then I will get 50y. The z will be cancelled off, which means I can get the y equals to 0 directly. So now I will substitute the y into the first equation. Okay, so from first, I'll get 22x. The 5y, it will be 0. Then minus 11z equals to 0, which means now my I can divide the whole equation by 22, which means I will get 2x minus z equals to 0. I do it by 22. Then my z is 2x. So means that now, okay, your z depends on x. I will let my x be t. Then my z will be 2t. After you get this, then we can express the matrix or the vector x, y, z. It will be your x is t, your y is 0, your z is 2t. Then I can factorize the t. It will be 1, 0, 2. So the eigenvector, okay, E1, it will be 1, 0, 2 when lambda 1 is negative 4. Right? So I have found the first eigenvector. So now we have to repeat for the other two lambda values. Okay? So I will repeat. So now when lambda 2 is, next eigenvalue is 6. Right? So here I will write 6. Then now by referring to this matrix, okay, you just change the bracket, the value inside the bracket by 6 now. So I will get 18 minus 6, 5 minus 11. So the second row becomes 8, which is here. 8, then 6 minus 6 minus 4. Okay, lastly, I will refer to last column, last row, 32, 10 minus 20, minus 20 minus 6. 32, 10. So 32, 10 minus 20 minus 6. Multiply with x, y, z equals to 0 for all. Okay, so now I simplify. Now 18 minus 6, you will get 12, remain the rest. Then the middle term will be 0. Then after that, third row will be 32, 10, and minus 26. Multiply with the x, y, z, and all will be 0. Alright, again now we form three equations. So 12x plus 5y minus 11z equals to 0. Let this be the first equation. Then 8x minus 4z equals to 0 because there's no y. Then 32, I will write 32x plus 10y minus 26z equals to 0. That is my third equation. Okay, so from the second equation, basically we can divide. Okay, divide the whole equation by 4. So now here, to save the space, so I can divide by 4, and then I will get the z as the subject. So my z is basically 2x. This is my second equation. Alright, so since the z is 2x, I can let x be. Just now I used the t, now I use x. I use u. That means my from second equation, I let x be u. That means my z will be 2u. So I found the z already. Okay, so now I substitute the this x and z into one of the equations, first or third. No, I made a mistake. I shouldn't let it be u first. Okay, I will have to substitute first. I have to solve first. But basically, we know that for eigenvector, we will be getting the infinite solution. Okay, so please ignore the previous step. So now I will solve this first. So it means I substitute second into first equation and substitute second into third equation. I solve the simultaneous equation first to double confirm my assumption just now. Okay, so I substitute second into first. I will get 12x plus 5y minus 11 brackets. The z will be replaced by 2x. Then from here, I will get 5y minus 10x equals to 0, which means my y is going to be 2x. Okay, then now I substitute second into third. So when I substitute second into third, 32x plus 10y minus 26, the z is 2x equals to 0. Then from here, I will get again 10y minus 20x equals to 0, which means I will be getting y equals to 2x as well. So which means now I know that my x depends on, my z depends on 2x, depends on x, my y also depends on x. So now I can let my x be u. Okay, which means my y is 2u and then my z is 2u. Okay, then now I will continue here. Right, so I will rewrite. So when lambda equals to lambda 2 equals to 6, I will get xyz equals to, so now my u, I get u, 2u, 2u. So here it will be u, 2u, 2u, which means now I factorize a u, 1, 2, 2. Okay, so my E2 is going to be 1, 2, 2 when the lambda 2 is 6. So repeat this for the next lambda. So my next lambda is 2. Here is my 2. So now I will write when lambda 3 is 2. Now, by referring to this matrix, just replace the values inside the bracket by 2 now. I will get 18 minus 2, 5 minus 11. So 8, 6 minus 2 minus 4, 32, 10 minus 20 minus 2. So I'm referring to this matrix. Okay, so then replace or multiply by x, y, z, then equals to all 0. Now, when you simplify, the first one will be 16. 5 minus 11, then 8, 4 minus 4, 32, this is 32, 10, then minus 22, xyz equals to all 0. Okay, again now form three equations. So 16x plus 5y minus 11z equals to 0. Then 8x plus 4y minus 4z equals to 0. This is the first, this is the second. And then the third one will be 32x plus 10y minus 22z equals to 0. This is the third. Alright. So now I can simplify this by multiplying the second equation with 2, second times 2, so I'll get 16x plus 8y, then minus 8z equals to 0. This is my fourth equation. So it means that now I can solve the first and fourth. Okay, the second becomes fourth already. So then from here, I can just minus. So it will be first minus fourth. I will get 5y minus 8y will be negative 3y because the 16x already cancelled off. Minus 11z minus 8z, it will be minus 3z equals to 0. Means my y is z. Okay, now I have the third equation. So basically the third equation is same as the first equation. You see, the third equation, I times half. Then I will get 16x plus 5y minus 11z equals to 0. This is my fifth equation. But actually the fifth equation is same as the first equation. Means that basically you only have two equations here, first and second. Alright. So therefore from here, I have the z value and the y equals to z. So now I need to find out what is my x. Okay, so I will substitute y equals to z into the first or second equation. I substitute into second equation to get the x. So I will get 8x plus 4z because the y has been changed to z. Then here minus 4z equals to 0. Okay, let me check my solution. Okay, I found a small mistake over here. This part, if I need to get the y as the subject, I will move it to the right side. And then at the same time, I divide by negative 3. Divide by 3. Then I will get negative z. Okay, a small mistake here. So here you have negative z. So now my y is negative z. So this will be changed to negative z. So I will get plus 4 negative z equals to 0, which means 8x minus 8z equals to 0. Okay, then my x will be z. So now I will let my z be w. Therefore, my y will be negative w, my x will be w. Right? Because of this. Okay, so now my solution will be w, negative w, w, which is 1, negative 1, 1 for my eigenvector. So now I will get E3 equals to 1, negative 1, 1 when lambda 3 is 2. Okay, so now for the final answer, we need to get A degree 5 is PD P inverse. So for your information, since this is degree 5, I need to consider degree 5 of the original matrix D. Alright, so now basically, okay, because I don't have enough space, so I will just show you here. So my D is basically degree 5 of my eigenvalues. So just now my eigenvalues Okay, look at here, minus 4, 6, 2. So I will follow this sequence. It will be minus 4, 6, 2. Because of the a degree 5, I have to consider degree 5. Then here, just bring in the degree 5 to the diagonal values. You will get this. Then I will get negative 1024, 0, 0, 0, 7, 7, 7, 6, 0, then 0, 0, 32. This will be my matrix D, and when P or N, P, I will write N. The P will be just the eigenvalues, the corresponding eigenvalues. Sorry, eigenvectors. So the first eigenvector 102, the second eigenvector 122, and the third eigenvector is 1, negative 1, 1. So I will just copy all this. 102, 122, and 1, negative 1. So this will be the final answer of this question. Okay. Now question number 6. Find the particular solution of the differential equation given t0, x and dx dt equals to 0. So now, right, I will let the right hand side be 0 first. And then my auxiliary equation will be a quadratic. So when you simplify this or factorize this, you will get m minus 6 squared equals to 0. Therefore, your m equals to 6. Now your complementary function will be x equals to e6t a plus bt. Okay, that's the CF, complementary function. Now, by looking at the right side, 337 sine t, that means my trial solution. My x will be p sine t plus q cos t. Then now I need to differentiate 2 times. So my dx dt will be p cos t minus q sine t, and then my d squared x over dt squared, it will be negative p sine t minus q cos t. So I let this be the second equation and this be the first equation because I didn't copy it. Okay, so now substitute second into first. So second into first, I will get minus p sine t minus q cos t, because the first term is d squared x over dt squared, then minus 12 dx dt. So minus 12 dx dt is p cos t minus q sine t. Then after that, plus 36x. So plus 36, the x is p sine t plus q cos t, that equals to 37 sine t. Okay, so from here, I will factorize the sine t and the cos t. So for sine t, you will get all these 3 terms. Okay, so I will get minus p, then plus 12q, after that plus 36p. Then I factorize the cos t, then the remaining term will be here, right? Then you will get minus q, then after that minus 12p, then plus 36q equals to 37 sine t. So by comparing sine t. By comparing the coefficient of sine t, so I will get, now when you get the total here, right, 36p minus p will be 35p. So I will just direct write 35p plus 12q equals to 37. This is my third equation. And then I compare cos t. And again, when I simplify, right, 36q minus q, it will be 35q. So I will get minus 12p plus 35q equals to 0 because there's no sign, there's no cos on the right hand side. So from here, my p will be 35 over 12q. This is my fourth equation. So now I'll substitute the fourth equation into the third equation. Then I will get 35 times 35 over 12q plus 12q equals to 37. So when you simplify this, the left hand side, the total is 1369 over 12q. Then right hand side remain, and then now your q will be 12 over 37. So now substitute into the fourth equation. So from fourth, your p is going to be 35 over 12 times 12 over 37. Okay, so you will get 35 over 37. So now your particular integral, your x will be, okay, refer back to here, p sine t plus q cos t. So replace the p and q that you have found. 35 over 12, sorry, the p is, this is the p, where is the p? Okay, 35 over 37 sine t plus 12 over 37 cos t. So now the general solution, it will be x equals to cf plus pi. So cf is complementary function, pi is particular integral. So now you will get E60 a plus bt, then plus 35 over 37 sine t plus 12 over 37 cos t. Okay, then now since you are given the values t0, then x and dx dt equals to 0. So now we need to replace. When t0, x0, which means 0 is E0, a plus 0, because b times 0, plus 35 over 37 sine 0, plus 12 over 37 cos 0. So now, sine 0 is 0, cos 0 is 1. Okay, so E0 is 1 for your information. Then from here, I will get 0 equals to a plus 12 over 37, which means your a is going to be negative 12 over 37. So now differentiate the x. So dx dt is going to be products rule. Okay, so I'm going to use u dv dx. So keep the e. Differentiate a plus bt is b, plus keep the a plus bt. Differentiate exponential, you just rewrite and bring down. So 6e60. Now, differentiate the sign, it will be positive cos. Then differentiate cos is negative sine. I'll get negative 12 over 37 sine t. Okay, and now let t be 0, dx dt be 0 as well. Then I will get another equation. Let me see. Okay, so I will get 0 equals to, remember just now E0 is 1. So I will replace it by b. Okay, here, this is 1, but it's 0. So here is 0. That means I will get 6a. Right? So I will get plus 6a. And then cos 0, it will be 1. So 35 over 37. Last term will be 0 because of the sign. So since we have found the a, then we can find the b. So now I will write 0 equals to b plus 6, replace the a that you have found, minus 12 over 37. Then plus 35 over 37. Okay, so from here, your b, okay, let me check. So from here, your b is going to be 1. Okay, when you move these two terms to the right side, it will be 1. Okay, so now the particular solution, just replace the a and b in the general solution. So now I have to refer to this. Okay, so your a is negative 12 over 37, so you will get E60 negative 12 over 37, that's a, then plus bt, your b is 1, so plus t. Okay, then followed by the sine and cos. Alright, so that's the solution of this question. Okay, now question 7. Use the substitution to find this integration. So your u equals to x squared minus 1. I need to get dx. So du over dx is 2x. Look at here, this is the x dx. So I will just group the x dx. Okay, I move up the x. These two I move down. So it will be half du. Okay, so now my integration of x over square root of x squared minus 1 dx, it will be, look at here, x dx. X dx, I will change to half du. So it will be half integrate du over square root. This is my u. Alright, so I will bring up the square root u. It will be half integrate u power negative half du. So then integrate this u degree half, because minus half plus 1, it will be half, then over half plus c. Okay, so the half will be cancelled off, then you get square root u. So square root u plus c, replace the u by the quadratic. That's the answer for this question. Okay, now the next part is the diagram shows a curve with equation y equals to inverse cos x together with n minus 1 rectangles of units width. By considering the sum of the areas of these rectangles, show that this is the inequality. Okay, so from here, we need to get the total rectangles. Alright, there are n minus 1 rectangles. So sum of areas of rectangles equals to, now look at here, this height is inverse cos 1. So we are referring to the first x, inverse cos 2. Alright, so I will get, because the unit width means that it is 1. So basically the area of the first triangle is just inverse cos 1, second one is inverse cos 2. So I will just add on all of them. Okay, wait, I did a mistake. This height is inverse cos 2. Okay, if it is inverse cos 1 is here, then I'm referring to the second ordinate, second one. Alright, it's not the first, it's the second. So it means that now for all the rectangles, I will get inverse cos 2 plus inverse cos 3 plus until inverse cos n, because the last is n. Then this is same as summation inverse cos x, okay, or I would say it is r. Alright, I use r instead of x. Inverse cos r from 2 until n. Alright, so in order to get this, you see, I have found the sum. Hang on, please. Okay, so in order to get this, actually I have found this. I need to get r ln. Okay, I don't want the inverse cos. So now you need to refer to the formula. So for the formula, okay, inverse cos x is ln x plus square root x squared minus 1, whereby the x is greater and equals to 1. So I'm going to replace it now. So it will be summation r from 2 to n, okay, ln. So now I will replace, this is inverse cos x, therefore x, I will change it to r, because I have written down here as inverse cos r. So ln r plus square root r squared minus 1. Alright, so done for the first part. Now for this part, I just need to integrate because it is area under the curve. So integrate inverse cos x. So now integrate, so this is area under the curve equals to integrate inverse cos x from 1 to n. Okay, from 1 to n. So now to integrate inverse cos x, I need to use by parts. Okay, so I will change this to inverse cos x multiplied by 1. So my u equals to inverse cos x, and then my du dx is 1 over square root of x squared minus 1. This formula is in the formula list. So dv dx is 1, your v is x. So now we are using by parts formula. This is the by parts formula. Right, so with limits, just add on the limits here. I will get x inverse cos x with limits minus integrate 1 to n x over square root x squared minus 1 dx. Then now when you replace the x by n, the first one will be n inverse cos n minus, when the x is 1, inverse cos 1. Then now minus, okay, when I integrate this, I have to apply another substitution method. So let u equals to x squared minus 1. Actually, this part you have done it, okay, which is here. Okay, exactly the same. Alright, so I will just write down this result, square root of x squared minus 1. So no need to apply this anymore. So I will just write square root of x squared minus 1. Okay, which is here. Exactly the same integration. Then 1 to n. This one is from a. Alright, so then I will get n. Okay, inverse cos n just now. Remember, I have this ln. So now I will replace my x by n. Okay, so you will get ln n plus square root n squared minus 1. Then the inverse cos 1 is basically 0. This is 0. Then I will get minus square root n squared minus 1. Then another minus. 1 minus 1 is 0. So from here, I'm getting n ln n plus square root n squared minus 1 minus square root n squared minus 1. So this is same as here. Exactly the same. Alright. So therefore, from here, you can just write area of the rectangle sum of areas of rectangle is greater than area under the curve. Okay, therefore you can just rewrite the summation r from 2 to n ln of r plus square root r squared minus 1 is basically greater than n ln n plus square root n squared minus 1, then minus square root of n squared minus 1. So done this part. Now for the C, use a similar method to find in terms of n and upper bound for this sum. Okay, so for this part, I have to refer to this part now. Okay, when upper bound means that your rectangle will start from here. Alright, so this is the upper bound. So we just change the, we just modify a little bit. Okay, so means that the first one is supposed to be inverse cos 1. The second one inverse cos 2. The last one will be inverse cos n minus 1. So then from here I will just write sum of areas of rectangles equals to inverse cos 1 plus inverse cos 2 plus until inverse cos n minus 1. So this is same as summation r from 1 to n minus 1 inverse cos r. Then again inverse cos r, use the same formula as just now. It will be ln of r plus square root r square minus 1. Okay, so the area under the curve is the same. Okay, so now from here I will write sum of areas of the rectangles will be less than, right? Because now your diagram, when you look at here, this will be the sum. So obviously the total of the areas will be less than the area of the graph. So area of the graph already found, which is this. Rectangles less than area under the curve. Alright. So from here, I will just write summation r from 1 to n minus 1 ln r plus square root r square minus 1 is less than n ln n plus square root n square plus 1 minus 1 minus square root of n square minus 1. Okay, so then now you need to get this. R start from 2 until n. But then right now I'm getting R start from 1 until n minus 1. So I will write summation R start from 2 until n ln of R plus square root. It will be the same as summation R from 1 to n minus 1 ln of r plus square root r square minus 1. Okay, now when r from 2 to n, r from 2 to n, that means it's here, 2 to n, it will be, because we have found 1 to n minus 1, so I need to get the total here. This will be same as, right now I have here up to this. Okay, that means it will be this total, the purple color, minus inverse cos 1. This is the inverse cos 1. Then I plus this. Okay, which means I'm getting the sum from 1 to n minus 1. I minus inverse cos 1 and then I plus inverse cos n. So then now inverse cos 1 is basically 0 if you use a calculator. This is 0. Then now I will get summation r from 1 to n minus 1 ln of r plus square root r square minus 1. Then this inverse cos n, I will just use a definition, which is ln of n plus square root n square minus 1. Okay, so from here I will say sum r from 2 until n ln of r plus square root r square minus 1. It is less than, because we have proven that it is less than here. Alright, from this. So less than, copy this part, copy, then minus square root n square minus 1. Just copy whatever here. And then here I need to simplify, right? I have one more term. So this is 2. Then after that I plus with the ln n plus square root n square minus 1. Okay? So then here will be less than n plus 1. When you look at this, here is the same. I factorize, then I will get n plus 1. Then ln n plus square root n square minus 1, and then minus another square root. Alright, so that is the solution of this question. Okay, 8a. Starting from the definition of secant and tangent, show this or prove this. So we know that secant t equals to 1 over cos t, which is 1 over half et minus or plus e minus t, which is 2 over et plus e minus t. Then for tangent t, it is sine over cos. Then you will get half et minus e negative t over half et plus e negative t. Therefore, you get et minus e negative t over et plus e negative t. Okay, so 1 minus secant squared t equals to 1 minus 2 over et plus e negative t. Then you square it. So here I will get 1 minus 4 over, do the expansion, 2t plus 2 plus e negative 2t. Then when you simplify, okay, get the same denominator, e2t plus 2 plus e negative 2t, just times by 1, I will get this. Then here I will get, okay, e2t minus 2 plus e negative 2t over e2t plus 2 plus e negative 2t. Okay, so this is basically the square of the tangent. So this is tangent squared t. Okay, so proven. Now B, given x, y, then you need to show this dy dx. So your x is half tangent squared t plus ln secant squared t. So our dx dt will be half, bring down the 2, the power 2, remain the tangent t, differentiate tangent t will be secant squared t. So for the ln, you will write over secant t, differentiate secant t is hyperbolic secant t, hyperbolic tangent t. So from here, the secant t will be cancelled off. Alright, then you will get the 2 also, 2.5 cancel off. Then you will get tangent t in common. Then I will get secant squared t plus 1. So secant squared t plus 1 is basically, oh sorry, there is a negative here. So it should be negative 1. Alright, then I will get tangent t times negative tangent squared t. Therefore, you are getting negative tangent cube t. So now for the y, 1 plus tangent degree 4t. So your dy over dt is going to be 4 tangent cube t and then secant squared t. So now your dy dx, it will be dy over dt times dt over dx, which means you are getting 4 tangent cube t secant squared t over negative tangent cube t. So then you will get negative 4 secant squared t. Okay, that is the solution. Now C, find the coordinates when the d squared y over dx squared is this and give your answer in this form. So now your dy dx, just now we have proven that it's negative 4 secant squared t. So now d over dt, dy over dx, it will be negative 8 secant t. Differentiate secant t is negative secant t tangent t. So then I will get 8 secant squared t tangent t. So now my d squared y over dx squared is basically d over dt dy over dx times dx over dt. So replace all the terms, you will get 8 secant squared t tangent t multiply with 1 over negative tangent cube t. Then from here, you will cancel off the terms. It becomes negative 8 secant squared t over tangent squared t. And you are given negative 9 over 2. So I will write negative 9 over 2 equals to negative 8 secant squared t over tangent squared t. So then 9 tangent squared t equals to 16 secant squared t. And now you solve this using the identity. Okay, and then you will get 25 tangent squared t equals to 16. Then our tangent squared t will be 16 over 25. Okay, so now replace the x because we need to get the point, right? So your x is half tangent squared t plus ln secant t. Okay, even though I get the second tangent squared t, I need to get second. So it means that from here, right, I need to get secant squared. Secant squared t is 9 over 16. Look at here. Tangent squared t. Therefore, it will be 9 over 16 times 16 over 25, which is 9 over 25. Therefore, my second t will be 3 over 5, given the t is greater than 0. Okay, so from here, I will replace the values. It will be half bracket 16 over 25 plus ln 3 over 5. Therefore, I will get 8 over 25 plus ln 3 over 5. There's my x coordinate. And then my y coordinates will be 1 plus tangent degree 4t. Therefore, it is 1 plus 16 over 25 degree 4. Then it will be 881 over 625. Okay, therefore the point, it will be with coordinates 8 plus over 25 plus ln 3 over 5. Then the y coordinates will be 881 over 625. That is my final answer. Okay, so with this, I have completed. Let me check. I have completed this question. Alright, so at last we have completed this paper. This is the end of the video. Okay, let me rewrite this. Alright, so thanks for watching. Please subscribe to my channel if you enjoy watching my video and stay tuned for more upcoming videos. Thank you. Bye.